We are live. My name's Weldon Dodd. I'm the SVP of Community at Kanji, which means I got to do cool stuff like this and hang out with Mac admins at PSU and other conferences. This is my favorite part of being a Mac admin is the people that are part of this community. So I just want to acknowledge what a great conference that PSU is putting on for us. From a speaker perspective, it's really well organized. We know where we're supposed to be at the right time. All the tech is set up and working, right? But also a really good job with just communicating with the attendees and sharing information and publishing these sessions and everything. It's really great. There's been a bunch of really good sessions already, and I appreciate the way that people contribute to the community and contribute to everyone who's coming here, right? And making the session about you, and I hope I can do that today, but just, want to call out Tom Bridge, right? Talking about software update in a way that's really about all of us and what we're trying to do with software update. Chilcote did great session and kind of pointed out at a few other people, including us. We're really grateful, right, to be included, but just a really good job of spotlighting other people and what they're doing and contributing. So I want to bring that same kind of energy into this session today as we talk about security. So my background, let's try Bluetooth here. It's one of those things that was working in practice and now has stopped working. But the part of the difference was I was doing it with Bluetooth earlier. Haha, I think I've fixed it. Okay, so you know who I am. I've been in and around Apple for 30 years now. I started my career in 1993. I was managing a Mac lab and a Next lab at the University of California. And then, a few years later, right, Next and Apple, the mom and dad got back together, right? And we got Mac OS 10, Mac OS today, and all the great things that have come from that. I did have some detours into different parts of the tech world, right? I was in cell phone networks for a while and did network management systems for cell phone carriers for about 10 years. But the last 15 or so have been back focused on Apple endpoint management. And I have to say, it just feels like home, right? This is what I love to do, and these are the people I love. So it's great to be with you. We're going to talk today about security, and I want to take a little bit of time at the beginning here to tell you how I see the world and how I think Kanji sees the world, and maybe try to convince you that you should think about the world the same way, right? But I think this feels true to many of us, right? That if we look back 10 years or so, right, IT and InfoSec had different missions. They had different mandates, right? So IT's job was squarely how to improve productivity for the end user. How can I support them and deliver the applications and services that they need? And InfoSec was focused on protecting corporate assets. And largely, that job was centered on network services and centralized services. Some of those shifted to the cloud, right, from on-premise, but still it was sort of this idea of, hey, we need to provide email file sharing, right? These centralized services. And InfoSec was thinking the same way, how do we protect the network perimeter? How do we protect these services that we rely on? And what I'm seeing is that today, these two teams are converging around the endpoint. So a huge focus for IT to continue to improve productivity for the users is to deliver an endpoint that's properly configured, has all the right applications and services on it. You've seen sessions at this conference about providing a good experience either through self-service or through automated deployment or whatever to get that device into the hands of the user properly configured and ready to go. Well, the endpoint is also becoming the focus of the InfoSec team because it's not all done, right? There's always work to be done. But a lot of those central services, a lot of those cloud services, we've figured out ways to protect them. And it's definitely not true anymore that the job is to protect the network perimeter, right? We live in an environment where people work from home, they work from anywhere, they're hybrid back and forth, in and out of what used to be the corporate network. They're inside and outside of that perimeter all the time. And the services that we use all day long, some of them, sure, are still inside of our perimeter, but a lot of them are hosted with AWS, with Azure, with Google Cloud, whatever, right? And so this world's changing, right? The job of InfoSec has a lot more attention and focus on securing the endpoint. And we've seen it in the news, right? That's a vector for an attacker to get entry into corporate systems. If they can compromise the endpoint, if they can compromise the end user, either through a vulnerability or some kind of exploit or through social engineering, right? That endpoint gives them access to lots of information. Even worse, right? You compromise an endpoint that happens to have, GitHub commit auth tokens on it, things like that, right? Some of those things we've seen in the news. Protecting that endpoint is a real focus. So these worlds are coming together. In order for IT and InfoSec to work together effectively, they need to have a shared view of reality. They need to have some shared data about the endpoint. And so bringing these systems together can help. From the IT perspective, right, you don't want to introduce tools that are going to kill productivity. We in this room might remember, the way it used to be when you'd introduce a DLP tool or a security tool, and it would just slow the system to a crawl as it was running through the file system and checking every single file, doing those kinds of things. Or you'd go to copy something, and now all of a sudden the system almost halts, right? So we don't want to do that for IT, because that means more help desk tickets, complaints, like IT's not doing the right thing. And same thing from the InfoSec side. It's one thing to detect an issue, but all the controls to manage that or mitigate it, to respond to that issue, are often in the hands of IT. So how can we share information to reduce the time from detection to action or remediation? So sharing data, sharing this worldview helps both sides. Okay. So the tools were kind of built, though, separately. Right? They kind of grew up independently of each other, like in different households. And so, IT had their set of tools. On the Mac side, MDM is one of the tools. I'm just paying attention to the audio in the room changing on me. But on the IT side, we have MDM tools, some other ones as well, but MDM's like the main one we have for Apple platforms, because it gives us those low-level entitlements to manage security controls and to lock things down, to take action and enforce security controls. And the InfoSec tools develop separately. And so what you have in a lot of shops is this sort of CSV shuffle between the two teams, where it's like, okay, I'm going to produce a list of computers that you should be worried about, and here's a CSV, and I email that over to the other side, right? And you take that CSV and go look in your management tools to go figure out what's going on, and maybe take some action or implement a policy to address it, and you ship that CSV of remediated devices back to the other team, and that's just not a very pleasant way to work, but it's not very efficient either. So some people have tried to work around this, CSVs, maybe integrations between two tools, but for me, that's not really the right question. We should be asking a slightly different question, not how to work around the wall, but what would it mean to tear that wall down, right? And to harmonize these two teams and the systems that they share. So how do we break this down? Well, one way is through education and just a shared understanding of what's going on with some of these security topics, so that I'm making some assumptions, right, about the audience in the room that we're mostly Mac admins. That is the name of the conference, right? But how do we approach our colleagues in security and sit at the table and have a really productive, meaningful discussion about how we're going to work together, using the same language, using the same terms, right? Working together to get this done. So I'm going to talk a little bit about Kanji, but I'm going to talk mostly about just some general practices that, and some general security topics that hopefully everyone can benefit from. Okay. So I've got this background image of the bass guitar up there because it's easy for me to relate things to music. So outside of being a Mac admin, like I grew up with music. I started playing the bass when I was 12, 11, somewhere in there, right? And I played for about 30 years. I finally had my 5th kid and I hung it up, right? And I stopped gigging and playing out and about. But I love music, and there's a lot of things in there that help me relate to these topics, and I'm going to bring a little bit of that into the talk today. I'm going to talk about these 4 areas of security. So just hardening your systems as a starting point, but then looking at vulnerabilities and managing vulnerabilities on a system, the threats that might be introduced there, how to address those and see them and what you could possibly do. And then we'll round out with compliance, which kind of covers a lot of these topics and brings them together. So hardening, okay, these are things that we're probably all doing already, right? It's kind of the core of being a Mac admin, getting MDM implemented, getting devices managed in the first place so that you can do the real foundational tasks like making sure disk encryption's turned on, you've got a passcode policy, et cetera. So relating this to music, it's a bit like, learning an instrument. If you want to get involved in a band, if you want to be in a band someday, like step 1, you got to learn to play. So, okay. So same thing here. If you want to get good at being a security conscious, a security aware Mac admin, first step is you got to learn to be a Mac admin. Okay. And a lot of us are already there, but I'll go through this pretty quickly. Just some basics, right? That should be part of everyone's policy, password screen lock, encryption. Everyone should be doing this already. The key here is that in order to set this up, you're going to use the controls that Apple's provided for you. So if you want to set a compliant password and have some options around complexity, minimum requirements, and so on, you could do that by going to each computer, right, and setting things up, but that's nonsense, right? You want a tool that allows you to do that at scale across your whole fleet and apply it consistently so you know that every device is configured exactly the same. So you want to use MDM for this. So Kanji, we have these kinds of options. You have something similar with whatever other MDM platform that you might be using. Another one is the lock screen. Okay, it's great that you set a password on that device, but if it never locks where it asks you for the password, that's not going to be a great solution. So you need to have both of these things in mind, okay? That, yes, we have passcode policy, but we also make sure the screen gets locked when it's been unattended or the screensaver starts or whatever. And there's this interesting interaction between those. So you can configure those as well. Disk encryption, okay? Again, having a password on the user account is nice, but if you don't have disk encryption, it's really kind of like putting a deadbolt on your screen door, because if someone has physical access to the device, they can just read the disk, and then the passwords don't matter because I'm reading the disk from somewhere else. Disk encryption is going to make sure that you can't get to that data. And again, the right way to do this is with MDM, so that you can not only enforce the consistent implementation of disk encryption on every computer, but also so that you can escrow the keys and hold all the keys in your IT department. So if a user, wins the lottery and they drop their laptop off on their last day and take off to Bermuda, right? You have a way to unlock that device and get access to important corporate data that might be on it, and then get it ready for the next person, those kinds of things. So it's not just enforcing the control, but it's also being able to manage it centrally and collect information like the encryption keys or the escrow key for the file vault centrally so that you have access to it. Like I said, these are all kind of foundational things that we should be doing, and there's many more that go into hardening a system, but hey, this is a really important part. If this is where you're starting with security, okay, that's what you need to do. There's no point in talking about these other things until you have that taken care of. Now, in my setup here about playing music, okay, being really good at your instrument is awesome. Being a really good Mac admin, that's cool, right? And if you can go like shred in your basement, essentially, right? There's a whole audience that would watch YouTube videos of you shredding your Mac, right? And being an awesome Mac admin. And that's super cool, right? You could totally do that. But if you want to be in a band, right, you got to learn to play with other people and incorporate maybe some other instruments into the music that you're playing. And so vulnerabilities here is one more way that we can kind of expand our practice and maybe join some conversations with colleagues around the company around security topics. So when we talk about a vulnerability, these are an exploit in a piece of software that you've probably deployed on purpose, right? Software that you're managing, that you want to be on your computers, but there's some available exploit in it. I've got this quote from Kevin Mitnick, who just recently passed away, right? So rest in peace, Kevin Mitnick. But he's alluding to this idea that there's a bit of a game of leapfrog, right, between attackers and the security response. And over time, attackers get increasingly sophisticated in the things that they can do. They have more tools to try to find exploits. Who knows what generative AI is going to do to these kinds of exploit finding tools, and their ability to like run through code at scale and try to find things. And then they build tools to exploit it. And then there's sort of a period of time where security vendors respond to that and try to implement something. But these vulnerabilities are in your environment, okay? And you invited them in. So when we talk about a vulnerability, we can break down the anatomy of it by looking at the National Vulnerability Database and the entries that are provided really by the community. It's a crowdsourced database of information about vulnerabilities or exploits. And if we go through this, there's quite a bit you can learn about how to understand the vulnerabilities that are in your system or in your environment. Okay, so we'll talk through this. The quick info section of a CVE entry has just some basic information. When was it detected? When was that first published? When was it last updated? The source here for this particular one that I chose for the presentation is Chrome. Like the exploit is in the Chrome app. The description tells you what it can do. So this is basically a memory bug. So it says here in the bottom line, it exploits heap corruption. So the system heap or that the memory stack for that application, there's a way to, I don't know exactly, right, but overflow that, read data that you're not supposed to be able to read from the application and use it for malicious purposes. So it's also possible in some of these to inject things into memory that then Chrome would use and do something different than intended because you injected something into memory that wasn't supposed to be there. Okay, severity is high on this one. The base score is 7.5. So the base score is just an indication of how critical is it, what's the worst thing that could happen using this exploit. There's other components to a score. So the base score tells you quite a bit. There's also a temporal component or a time-based component. And so what that tries to represent is over time, Like, we'll get a better understanding of the exploit. We might have better detection methods or more reliable detection methods, and we might have a mitigation available. And so that temporal component will change, right, as the environment changes, as things change. The other component to a score is the environmental component. And so what that means is, how does this vulnerability relate to your environment? So for example, like this is a Chrome issue. If you don't have Chrome in your environment, which, let's face it, everyone has Chrome. But if you didn't have Chrome in your environment, then this doesn't apply to you, right? The score drops to 0, right? The environmental part of it is 0 because you don't have Chrome. But you could look at other exploits and make a determination, within your team, maybe working with some other people, does this exploit actually affect us? Okay. Now this one's pretty straightforward. It's just Chrome visiting a web page that has malicious HTML in it that can exploit this heap corruption bug. But you could imagine some other ones, right? Where the exploit might be, hey, if you have an admin account on this computer and you have global admin rights to the Active Directory domain controller, then you can do something. Okay, well, let me look at my environment, like who has admin rights on their local box and who's a global admin in Active Directory. I've just reduced that attack surface, right, to a manageable number of people or a manageable number of potential devices, and I can score this for my environment and decide if this is something I need to take action on or not. So just because the base score is high doesn't necessarily mean that you need to drop everything and take care of it for your team and for your environment, but you need to stop and consider the temporal component, but also this environmental component. Okay, what does this mean for us? Is this something I need to worry about? It's definitely good to be aware of the high CVSS scores that you have present, but again, you don't necessarily have to take action on each and every one of them. You want to know what they are. If someone asks you, you want to have an answer, right? That's important. But the answer could be, we chose not to do anything about this one because it doesn't affect our environment. It's not valid here where we work with our conditions. Okay. Some other information. The attack vector here is the network, right? So it's the Chrome browser opening a connection to a web server and getting some HTML back. The complexity is pretty high, which indicates the attacker has to be fairly sophisticated in order to use this and take advantage of the exploit. Does not require any privileges. So that's a warning sign that it doesn't matter if you're an admin or what your privileges are. It just uses this Chrome bug to have Chrome execute code. It does require user interaction. The user has to go to that website that has the malicious HTML in it. If the user never goes there, nothing can happen. So again, your answer might be, well, we'll just block those sites, right? Or we have a network content filter that's sophisticated enough to be aware of these, and it will detect it and block it for us. Things like that. The integrity and availability scores are all high here. That leads to an impact score of 5.9 and the exploitability score 1.6. That's where we get our 7.5 base score from. So when you're reading this, right, you can put all these things together to kind of understand, all right, this is what this CVE is describing. This is what I need to know about it. Okay. Down here at the bottom, the enumeration here of the weakness is a reference to a type of exploit. And so this particular Chrome exploit is following the pattern of CWE 416, which was use after freeze. So when the memory gets freed by the application, they're able to inject something or read something from it. And so it follows this pattern. So you could you could learn a bit more by following that link out. There's a whole bunch of exploits that use the same type of exploit. And this Chrome one happens to use this type. You could learn more about it. The known affected software configuration lists the version numbers of Chrome that are, so in this case, it's up to, but not including 112, 0, 5615, 137. Okay. So you could look at your environment again and say, okay, does this affect us? Do we have anybody on this version of Chrome or lower? I can't decide if it's later or earlier or whatever, but a lower version of Chrome, then it might be an issue. But if we've already patched all of our systems to a later version of Chrome, the CVE doesn't apply to us anymore. Okay. All right, so vulnerabilities. When you start playing with others, right? You invite somebody else into the band, and you realize like they might have some issues. Like, I really want Chrome here. I need Chrome. We're a Google shop or whatever, right? But Chrome has some issues. I've had a few bandmates like that, right? That have come in. You realize, okay, I like what they're doing, but they've got a few issues. You just need to take stock, understand what the issues are, what's our plan to manage them, does this affect us or not? Okay, and we'll work it out together and manage the whole situation. I thought of the Taylor Swift song, right? They tell you who they are, right? So just believe them and use that information the best you can. I got to see her show just the other week in Denver, where I live. Amazing performer. Like, if you do or don't like Taylor Swift, fine. But I have 2 daughters and a wife and a daughter-in-law, right? So Taylor Swift is on repeat in our house all the time. And I guess it's like Stockholm Syndrome. Like, I love it now. I'm way into it. I was super excited to go to the show. And she's an amazing performer, right? So you talk about being someone who can do it all. Like, she really can. Singer, songwriter, great performer, really good. So something to think about, I think, for our careers too. How can we grow and do multiple things, kind of take it up to the next level? Well, one of those ways is threats. So we just talk about vulnerabilities. Well, a threat generally, right, is software that you don't want on your systems, okay? Where a vulnerability might be introduced by some tools that you installed on purpose, that your software that you want. Threats generally are software that's unwanted and unwelcome. So that could be a whole range of different things, right? It could be adware, just kind of nagware stuff. Something really benign like somebody inserting an album into your iTunes library without you asking for it, right? Which is pretty low on the risk scale. Or to something really bad, like ransomware, where it's encrypting files on your system and you don't have access to your data anymore because someone wants a Bitcoin or 2 for it, okay? So let's take a look at what these threats are. There's malware, which kind of, could include lots of different things, right? And PUPs, or potentially unwanted programs. And the distinction between the two is a bit fuzzy, but let's just talk about these 2 broad categories, right? Software that is doing something bad, is designed to be malicious, and software that maybe isn't super malicious, but we don't want it there. Like, PUP could be anything from, World of Warcraft to FileZilla to MacKeeper, right? So, FileZilla's fine tool. It does FTP great, right? But the later versions have ads in them, and you might have a tool that you prefer that you would really want your users to use and not that one. And so you would classify it as PUP because you don't want that unapproved tool with adware on it, even though it is potentially useful. But let's look through a threat. Really, there's 3 things that compromise or compose the threat. One is trying to infect your system, okay? It needs to get installed and get on there so it can run. That's job one. Like, how can I get this software onto a system so it runs? And once I'm there, how can I stay there? So me being the malware in this sentence, right? Once the malware is there, how can it stay there? And make sure that it'll run again if you log out or reboot or whatever. And then, of course, it's trying to actually do something with its access. So that impact, well, what is it that it's trying to do? We'll look at each of these three things. How does malware typically infect a computer? What does it do to persist? And what kind of impact is it trying to make? So some common methods, user interaction. So like on the Windows side, right, how common is it to get those web ad pop-ups that say, hey, 27 issues were found on your computer, click here to download some software that's going to help you out. It's always kind of a bit humorous when you're on a Mac and you see a window that looks like a Windows window, right? And you realize that what they're trying to do here is make it look like a system dialog or look like a system window. So there's some of those. Could be, it could just be something like MacKeeper, I mean, not to pick on them too much, but, it presents itself as being useful and helpful software, but it's loaded with ads and it does a bunch of other stuff that's generally not good. There could be an exploited vulnerability. So there's some other exploit available on that system, and an attacker could use that to install their software, get it running. Could be from the supply chain, right? So that's something we're really conscious of as an MDM vendor. Like if you're using our tools to deploy software, we want to try and make sure that we're not deploying bad software. Put a lot of energy into that. So we've been picking on MacKeeper. We could take a look at that, but just a quick history. First viruses started in the early 70s, and then we see the first antivirus product to try to identify those and remove them. But then, all those early ones were being distributed on disk and things, USB stick, whatnot, but then the internet comes along, right? And now we're distributing files across the internet and downloading them from websites, and so just the whole game got leveled up. We talked about that game of Leapfrog that's happening. So the internet comes along, new technology to use to exploit. Apple introduces a whole bunch of new technologies in the early aughts to address this. Quarantining files that got downloaded from the internet, so the user has to click through a dialog to have something run. It won't just run silently. The malware removal tool, XProtect, Gatekeeper, all that gets introduced. The first EDR tools show up around 2013, which are doing more than the old just signature-based antivirus. The problem with signature-based antivirus is that if you change one bit in the file, that signature doesn't match anymore, even though it's doing all the exact same things. Your software doesn't detect it. So EDR is getting a little more sophisticated, right? Kind of trying to catch up in that game of Leapfrog. Last year, we got some more updates to MRT and XProtect, but the big news and kind of the best way to detect malware on the Mac is provided through the new endpoint security framework. So introduced a few years ago, this is a really high performance specialized API to watch what's happening on disk with files and some other components so that security vendors can build their tools to be able to detect threats in close to real time. We talked about the kinds of slowdowns that would happen with the older tools, where it's like just looping through the file system and reading every single file. ESF is essentially a fire hose of data about what's happening with the file system and new files that are getting created. And it provides security vendors the ability to ingest all that data very quickly in a really performant and sort of low resource cost method to do it. So it's a platform API for all this stuff, which is great, which means that we don't have to write tooling to go through and inspect every file on our own and do it through the regular like Finder APIs, which would be super slow and big drag on performance. We can do it through ESF. So we'll take a look here. In this next video, we're just downloading MacKeeper and seeing what happens when that disk image comes down and we run it for MacKeeper to install. So this is output from ESF. And I know it's small text and it's kind of scrolling by because there's like these events are flying by. But in something like 16 seconds or so here, you can see all these Safari events where it's downloading the file. The file gets modified a bunch of times. We highlight some sections here. File gets modified, it gets cloned. So there's a temp file that Safari uses to download it, gets cloned to another file, creates that, renames it, bunch of modifications, other things that happen over these 18, 20 seconds or so, 16 or something. Okay. Now we're doing the same thing, but we've asked the Conji agent to watch the ESF output and look for this pattern of a file getting downloaded, modified, renamed, moved, all these things that happen with MacKeeper to try to obscure what it's doing and where it's going and where it's putting files. And we're asking the Conji agent to watch ESF output and identify that behavior, right? There's this file that just got downloaded that's now doing a whole bunch of stuff. So again, the video kind of flies by here and it's kind of impossible to follow exactly what's going on, but I wanted to show you real output, even though maybe it's not very accessible in this format, but this is the real stuff. So again, we have this file created and modified and whatnot, but pretty quickly we start, our tool goes in and starts modifying those files to prevent them from running. So they can't be executed. They won't run on that computer. So we're quarantining that file. And so the net result here is in just a few seconds, we've seen all this activity and we've quarantined MacKeeper. It will not run. And so now the threat to your systems has been reduced because it's pre-execution. Right? Some security tooling relies on, okay, well, once it starts running, I'll see what it does. I'll look for a process that's running in memory, that kind of thing, and then shut it down. But there's that window of time where it could be doing something malicious. So being able to identify this set of files in the file system pre-execution is a huge advantage for securing a system. Okay? I never had the chance to run. So what's nice about MDM and EDR together, right, is that you need MDM to deploy EDR tools. MDM is the mechanism to provide the entitlements for that tool to get full disk access. It's the mechanism to grant the ESF entitlement. There's a bunch of other things there. So deploying it is greatly simplified when it's together with MDM. So take a look here at Conji. So, okay, so this is the Conji interface. We're gonna filter the library items down to the security ones. This is our Avert library item for the EDR. We're just giving it a name. We're gonna assign it to a blueprint, which is a set of devices. And there's just a couple options here to configure the security posture. Is it in detect mode, like read-only mode, or is it in protect mode where it's actually gonna actively quarantine the files that it encounters? So now if we go look at a computer that's in this engineering blueprint, there's a bunch of other things assigned to it, but this endpoint security item is assigned there. So if we look right now, there's 0 threats. But we go to a system, we have this zip package that has a bunch of malware in it. And as we go by, we can see there's 40-something items. And now it's starting to go down as it goes Bind ticks through here about 14, it starts to go down quite a bit more, and 17 and 18 seconds, like they're all gone. So, it's just a quick example of identifying that malware and taking care of it. When we go back to the console and see the status, we can see that there is 59 items identified, 56 malware, 3 pups. But the status on all of these on the far right column is they've all been quarantined. So like MacKeeper is the top entry there, but there's some other ones we threw in just to test it, right? Make it work for its money. But you could see like that directness of, okay, deploying this to my systems is really pretty straightforward. Conji agent's already installed because we're managing all those devices. We just enable the EDR component of it. So it's looking at ESF on all those. When it sees something suspicious happen, it's in protect mode, so it quarantines all those files, and we can see the status in the console. What's nice too is, whether you use our tool or anyone else's, what's nice is being able to combine that information. Like I know a bunch of information about the endpoint through MDM, and now I've got more information from my security tools, and being able to compare that information back and forth directly is actually pretty useful. And that goes back to what I said at the beginning, right? About the world that we're in today, and the need for these two teams to talk to each other, and the need for this information to be useful together. So again, like even if you're not a Conji customer, I hope you can kind of see the utility of it here, and the ways that you can think about, okay, if I can know more about the threats that are potentially affecting our organization, if I understand more about our vulnerabilities, even if I have a separate InfoSec team, like now I can come to the table and have a conversation with them that is maybe one step elevated, right? And we can be true partners in figuring out how to respond to issues that might be coming up in our environment. So we get to, these infect portion, we want to blow that away, right? And just say, hey, you're not welcome here, okay? We've got all this together. And, tying it back to the music analogy, when you go out into you've got your band together now, right? You want to go out into the real world and actually play in front of an audience. You don't know what you're going to face, right? Maybe the mixer works, maybe it doesn't. Maybe they have power and maybe they don't, right? The same way that you take a Mac system and put it out in the real world and into an unknown environment, and things are going to come up. You need to be prepared to protect yourself and understand what's going on and make sure you're ready to go and you can get your job done regardless of the environment that you're in. Okay. Persisting, just real quick. This is really pretty straightforward on macOS. This is the good news, right? There's only a few ways for a program to run after a reboot or after a log out and log in. And so there's defined places you can look. Now, there's a lot of them, right? When some of you might know Eric Dreyer, right? So Eric and I worked together on some of that macOS Support Essentials training, and one of the things that we found was we tried to catalog all the places where you could install launch agents and launch daemons, and I think we stopped around 17, right? There's like 17 different places where they could get installed between system and users and everything else. So it's kind of complex, but it's a known quantity, right? You can go and look for launch agents and launch daemons and all these places and identify. I threw login items in there as well. It is another way, but just one more thing to check, right? There's not that many ways that software on macOS can automatically run when the computer starts up. Okay. So lastly, impact. Okay. The mild cases are like pop-ups, adware, changing your search engine in the browser, those kinds of things. But they do have an impact on productivity, and they might generate help desk tickets for you if your team runs help desk as well. Like that's a hassle when someone calls up and says, hey, I'm trying to Google something and it's not working, and then you find out they got hijacked. Did anybody go to Charles Edge's session yesterday? So he talked about extensions, right? And it's kind of scary what extensions can do, particularly browser extensions, because they don't require any kind of entitlement. They just get installed and run, but they have access to the browser and can do all kinds of things. So, that's one of those things where the impact could be mild or annoying or a loss of productivity, but it could ratchet up to something like data loss, right? Where they're scraping the forms as you fill them in, or there's ways that browser extensions can replay passcode, the passkeys, right? And things like that. So, there's a whole range here. And then, of course, the really bad ones, corporate espionage, DLP, right? Transferring files off of the system, sending them somewhere, or hijacking, or ransomware, those kinds of things. Okay, so that impact range could be quite wide. But having a handle on what's happening and what the current threat landscape is and what your exposure is like and what's happening on your own systems, right, is the place to start. You can evaluate impact from there. Okay. Compliance. So, the output of all of this work often shows up in compliance. The hardening, managing vulnerabilities, managing threats, a lot of times comes together in compliance. Maybe a bit like, putting on a show, right? You've learned a song, you've able to play with others, you brought some other instruments in, right? You got a nice sounding arrangement, but now you could put it all together into an actual show. And compliance can work like this. So there's really 3 steps to compliance. Step 1, there's guides that a lot of us are going to follow. They could be industry guides, or they could be government regulatory requirements, right? There's a range of different guides. We'll go through some kind of audit process to see how we're doing against that guide, and a report will come out of that. So some examples of guides: CIS. Alan had a really good workshop on day 1 about NIST as an example, right? So that's a great one to review and see. GDPR, HIPAA. If you're in different parts of the world, is anybody not from the US here? Okay, but in Australia, it's Essential 8. In the UK, Cybersecurity Essentials and Security Essentials Plus, and so on. Some of these different guides come into play. So if you're not in a situation where you're required to follow a particular guide, okay, 1, that's nice place to be, okay? But they're still useful to you because you can read through them and identify, okay, out of all these controls that have been laid out in these guides, which ones are important to us? Which ones do we want to adopt as our security policy? And that's the piece I want to encourage you to do, right? Is don't say to yourself, well, we don't have a requirement here. No one's imposing a particular security framework on us, so we're not going to do anything. That's probably not the right way to think about it, right? What you should be thinking about is, hey, a whole bunch of people have contributed to these guides, and there's a lot of really good information in here. So let's use what other people have done so that we can build our own security policy a lot faster, and we can identify the things that are important. Now, there is a bunch of nonsense in a lot of these guides for Windows. And so you do need to take it with a grain of salt when you go through them, that there's going to be a bunch of controls that aren't going to apply to managing your Macs. But that's the beauty of still being able to read through it, select what applies to you, what you want to implement into your own policy. Okay. Now, an audit could be an external auditor, but it also just could be an internal audit. So again, if you're in the situation where you don't have to employ an outside auditor to produce verified results, it's still a good idea to run an internal audit and to see how you're doing against your own security policies. Some options might be, hiring a firm to do pen testing. So like that's something that we do because we're providing a service to other people. We want to get outsiders to take a look and see what they can do to, break kanji, so that we make sure that those holes are not available, right? That no malicious attacker has any way to get in. So we do that. Our customers are always asking us about SOC 2 and that we can attest that we're SOC 2 compliant. Not everybody here is going to have to do that, but there's a bunch of really good learnings, a bunch of things that you can apply to your business, even if no one's asking you for a verified SOC 2 audit result. Okay, but it can go on, right? What happens if a system gets compromised? What happens if we lose access to a service? What if someone gets access to our GitHub repo or our AWS admin account? What's the business going to do, right? And thinking through the implications of the potential risks and identifying what those are and how are you going to respond to them, that's all useful. Okay, and lastly, the report card. So I mentioned SOC 2 is one example. Having that verified result from an outside party is useful for us. It helps our customers feel good that we're doing the things that we said that we're doing. But there's others. The one way to think about this is, of course, being able to present the results to someone else and say, yep, we did it. We did the right thing. We're doing good. Another is a way for your team, your IT team or your InfoSec team to score themselves and say, how are we doing? Like, are we fulfilling the mission that we have as an organization? It's my view that more and more the job of IT, the mission of IT is going to be viewed through that lens of compliance. Here's what we're trying to achieve. This is the goals that we have. This is the kind of security posture we want to achieve. And this compliance is a way for us to score how we're doing and show that we're fulfilling the mission that the organization's asked us to do. Okay. We've been through different trends and fads in the past, right? Service catalogs and ITIL and, all that, right? There's been different trends to kind of help identify and score what IT is doing and how well they're providing a service to the org. I think compliance is coming up that way. That in order to show that IT is delivering value and they're doing what they say they were going to do, it's going to be scoring yourself against a compliance report. Like, we delivered the applications, but they're compliant and secure and they're patched and up to date and so on. Okay. So there's this whole journey here, right? From being a musician to being an artist to being a rock star. I could definitely see that at that Taylor Swift concert, right? I remember 17 years ago when she started her career, and she seemed like a little, not to be dismissive, but she was a little girl, right? Very talented and, great. And now she's just a verified rock star. She's doing 130-something shows, 140 shows across the world, filling stadiums with like 80,000 people. 80,000 people. There were 73,000 in Denver, right? In 2 nights, sold out. And one of the things I was paying attention to during that show, it's kind of amazing. It's hard to describe just with words, but the stage is enormous. So it's a big football stadium, Mile High Stadium in Denver. And at one end of the stage is this ginormous LED screen that's 40 feet tall, and it must be 50 yards wide or something, right? And the stage extends out a good 50 yards in front of that screen. And there's a part in the middle where it bulges out, whatever, and it comes out to a little like hammerhead thing at the end. It's huge. And she's going up and down this stage, and it's 3 hours and 15 minutes, right? It is a long show, and there's a lot going on. But I paid attention. In the middle of the stage, there's these platforms that that go up and down. And so sometimes they pause on those and the platforms lift up and she's there with some of the musicians or sometimes with the singers or whatever. But it creates this like economy of energy, right, within the show that she gets to like plant herself in one spot and stay there for a minute and sing a song, and things are happening, right? There's movement and interest and there's other stuff going on, but she's actually getting a chance to like rest and conserve a little bit instead of just like running for 3 hours. And so I think there's a connection to our job, right, as Mac admins, that it's just not feasible to run all day long, right? 8, 9, 10 hours a day, just run like a chicken with its head cut off. That's sort of a bad visual, but run like a banshee for the entire day. Like, it's just not sustainable. There's all these things that we're being asked to do, right? We want to deliver an awesome experience for our end users. They get productive with their device. But we need to deliver all these applications. They need to be patched in a timely way. We need the OS updates to happen. We've got to get these security controls in place. We've got to have a security policy in the first place. We've got to audit ourselves and produce a report about what we're going to do to make things better. There's a lot going on. So part of the answer here is to figure out, okay, what can you do now? What's accessible to me? What's available to my team? What kind of steps can we take to move ourselves in the right direction? And where can we get help and use some automation or use some tools that will help us along that path? So we don't have to spend the entire show running up and down the stage, that there's some moments where we can let, like, the little platform things rise up and do some of the work for us and take some of that attention away, and then we can get on to some other things that we need to do. All right, so this is our approach to building tools. We want to bring all this together. I showed you a little bit today. I can show you a little bit more if you like, but the idea is, hey, let's bring MDM together with other security tools like EDR, like vulnerability management and compliance, visibility of all those components, so that IT teams and security teams can talk together. Or maybe some of you are both, right? That you are IT and security. And so giving you tools that allow you to be more efficient are going to help you out. I was talking to the gentleman in the green shirt here about his experience with flying out, where it was a little puddle jump kind of flight from, I've forgotten already, Philadelphia over here to State College. And the pilot was out on the tarmac inspecting the wheels and looking up in the wheel well and doing some stuff, right? And in a big plane, on a big flight, right, you've got a huge team of specialized individuals that are all doing their piece, right? And it's not the pilot going down to the tarmac to inspect the wheels. But on a little flight, on one of those small planes, it's the same guy, right? Or gal, right? Wearing multiple hats. And so I was just thinking about his experience with the flight. That's a lot of our experiences as Mac admins, is sometimes you're in that role where you're responsible for anything that's plugged into the wall and uses electricity, right? That's part of your job. And you've got to learn how to do all of that. Some of you are in bigger teams where they're a little more specialized, right? And there's different areas of concern. But even in those big teams, right, having a view of what your teammates are doing with security and like how you can participate in those conversations and have a seat at the table when you're talking about what security means for your business or for your organization is really important. Okay, so we think these benefits are enormous. Like, this is where the world's going. The end point is the convergence of productivity and security. That having a view of your endpoints that incorporates like all the rich intelligence from MDM and intelligence from security tooling gives you a better overall understanding of what's happening on those endpoints. And then being able to recognize a risk and then take action on it immediately, because those tools talk to each other either through an integration or some automation, or because they share a platform, it's going to lead to better results. And all of this leads to a reduction in overhead, like a more efficient response, a better way to work. Really, like one of my dreams, to be honest, right, is to build tools that help Mac admins be more effective. Because like patching Chrome is important. Like we spent some time talking about a CVE for Chrome. Like that's a real thing that you have to do, okay? But I don't think anybody like has a poster up on the wall that like my mission is to keep Chrome updated, right? Maybe it is, but I just don't believe it, right? Like, but what I do believe is that you do have a mission up on the wall. There's something that you're trying to achieve or that your organization is trying to achieve. And part of my dream is to be part of a company that builds tools that that gives you time to let you focus on what your mission is. And how are you going to have impact to your organization and how are you going to make the world a better place, right? Even if it's just in your small corner. And what I want to see, what I want for this world is I want Mac admins to be able to step up their game and be at the table when the organization's talking about how they're going to use technology to achieve their mission, right? And you're not just the Mac admin, but you're the guy who understands the platform that you're supporting, what the users need, and how to deliver it in a secure way and protect your organization. So that Apple native experience is really important, right? How many of you have mixed environments? About half the room. And when I say mixed, I meant Windows and Mac, right? Yeah, so about half the room. So a lot of companies have adopted a choice program where you say, hey, you could use either Windows or you could use a Mac. And I think it's really important to understand that when users are given a choice and they pick a Mac for their productivity platform, there's things that they want from that experience. They chose that platform for a reason. And so having tools that enable that experience or help you deliver the experience that they're looking for is going to be really helpful, right? And tools that don't focus on creating an Apple native-like experience are maybe not going to deliver what the users wanted when they chose Mac as their platform in the first place. So I've got some resources listed up here. We'll get the slide deck over to the organizers. So if you want, you can take a picture or you can pause the video at this point when it gets published and follow up on these. But just some resources for you to continue to learn more and add to your understanding and kind of up-level your game a bit with all of this. So thank you. We've got some time left. So we have this fancy Catchbox microphone. So I want to open it up to Q&A. Like what, you have any questions or anything you want to know about security or anything you want to know about Kanji? Let's go.
I'll start off.
Okay. I don't know if I can hit it all. Hey. Okay.
Maybe it's on, maybe it's not. So I'm curious, and I'm sure this is with all EDR tools, but during the demo, obviously, like malicious, like malware gets quarantined. Obviously, like seeing the demo, not understanding it, it seems like it just kind of goes into an abyss. What actually happens to those files when they're in quarantine? And an example where if it catches like a false positive, what would be that sort of like remediation?
Yeah. No, great question. So just in case that the mic over there didn't pick it up, the question was, when the files got quarantined, what actually happens to them? Where are they going? What's happening there? And then what can you do if there's a false positive, if something got quarantined that shouldn't be? So what we do when we quarantine the file is we take the file and we encrypt it, and then we move it to a different directory that Kanji controls. So by encrypting it, it means it can't be executed directly. We still have the file, so if we need to inspect it and look and understand what the threat is or decrypt it because it's a false positive, we can still do that and restore the file. If there's a false positive, then there is a place in the kanji interface where you can adjust your global allow list. And so you can say, okay, for this, this file hash, that's a trusted file. Don't identify it as malware. And so like the FileZilla example is a good one. Like we would, actually, I'll double check with our threat intelligence team. But that's the kind of thing where we may automatically identify it as a pup because of the adware component, but you may say, hey, well, it's freeware, we want to use it, people are used to it, like we're okay with FileZilla, and then you could just put it on your allow list. Okay. What else? Come on. What do you want to talk about?
Whose job is it supposed to spearhead these security initiatives? Because it seems like in my organization, even though it's very large, I come to security quite frequently for this platform, and I'm like, well, what would you like me to turn on?
Yeah.
And
Yeah.
the use case is, well, these people are developers, they need to be able to do their job. And I'm like, well, do you understand? I don't think there's an understanding of, well, they need to use tools like Homebrew, and there's certain pseudo commands they think they need to run, whether they do or not. And then there's also enterprise privilege management in play, right? And so I think just like you said, breaking those walls down, it's hard to start the conversation when it's being driven kind of like from the endpoint manager up to security. So just thoughts on that maybe and
Yeah.
start the conversation.
Yeah, for sure. And I'd be interested in what other people think. But just to repeat the question, it's, who drives those conversations about security? And sometimes the experience can be coming to a conversation and being told what needs to be done, or just coming to the conversation and asking, what do you want me to do, right? Like, what are we trying to accomplish here? Some other elements were brought in, like developers. Developers are installing tooling all the time. They're downloading stuff from the internet and using it, Homebrew or anything else. Like, how can we create a flexible enough policy that we can accommodate their needs, but still secure the rest of the organization? So this is like a really rich topic.
And I don't want to interrupt and say, and meet something like, we'll just throw out CIS level 2.
Yeah.
Or 1, right? Because that's the challenge point. It's like, how do we meet that and still curate that without necessarily moving to something like Amazon EC2 Max that are like fully sandboxed and compartmentalized and blown away every time they use them or something, right?
Yeah. So I mean, I'll show you just for fun. I'll show you one thing in Kanji, just related to CIS level 1 and 2. You can create a blueprint and choose from these templates here. It will create all the settings you need to achieve CIS level 1 or level 2 scored compliance with one click, right? So that's kind of a cool feature that we built in. But yeah, I think the bigger conversation here, just going back to that, I think it's really important for organizations to understand that, hey, you can choose whatever you want to do. Like, if you want to make users admin or you want to make users standard, like, I really don't have a strong opinion on that. You do whatever you want. What I do feel super strongly about is whatever choice you make, accept the consequences of that choice, right? If you're going to make your user standard, like one of the long-running issues on macOS is that standard users are not part of the LP admin group, so they can't unpause a print queue. So if they get into a situation where their print queue is paused, they can't fix it on their own, right? So you as an admin, like, just understand what you're doing when you make them a standard user and then fix it. Like, either, add everyone to the LP admin group, or, give them a self-service tool to escalate their privileges temporarily, or whatever. There's 1,000 different ways to address the problem, but like, understand what you're doing, accept the consequences of that choice. If you make all you users admin, fine. Like I run a bunch of teams that way and departments that way myself. I think it's totally fine in most situations. But understand that they're admin, they can change things on the system. If you don't want your users to change certain things, then make sure you have MDM enforcement in place, or you have some monitoring, because let's face it, there are some things that you can't enforce with MDM. Have some monitoring in place to watch those items, and if they change it, automatically change it back, right? That's part of what we do.
It's just configuration management, you decide on the tooling or whatever.
Yeah, make it work. Question in the back.
Yeah, so we use Kanji, but not the threats product yet, or in
Yeah.
the product. But I was curious, when you showed like the CVEs for a particular like infected version, does Kanji work off of that as well? Because in our environment, we use OS Query to find an affected version, and then we get an alert based off of that policy, and then we can go in and remove it. But does Kanji automatically remove based off of an infected version?
Yeah, so for the protect mode, right, when we quarantine a file, if we detect that it's vulnerable, right, or if it's a threat.
But do we do as admins, do we set the threshold? If it's like CVE 8 and above, do this, or lower? Like we all you don't always don't want it to be removed, but can you pick what action happens?
Yeah. No, what we're doing is we're focused on the threats, like the known malware and the pups. And for vulnerabilities, like our approach there is really just to focus on automated patching. So if we look like in our library here, and some of you may not be familiar with the Kanji interface, but these are all the items that you can apply to devices. So it includes things like App Store apps and OS versions and whatnot. But we also have this auto apps catalog. So there's about 140, 137 or something today. We add one every week of different applications that you can deploy to your users. So, if we pick, I don't know, so what's like Slack, right, is a good one. If you pick Slack and if you want to deploy this, you can just add and configure, one click, and now Slack's deployed. Kanji will automatically update Slack anytime a new version comes out. If Slack was installed previously by users or is already there from some other tool or whatever, we'll still adopt that application and patch it automatically for you. So that's kind of the main thing that we're doing right now for vulnerabilities, is just to make sure that we've automated the patching routine so that you can get to the latest version as quickly as possible. We definitely have some thoughts about how to add information from the National Vulnerability Database and do some more interesting things with it, but we don't have anything out right now.
Okay. If you want to talk, let's do it. Because I would like to see it integrated in Kanji, because now I
Yeah.
do it in 2 platforms.
Yeah.
I run the queries in OS Query, and then I find it in Kanji.
Yep.
It's a lot of it's not auto apps. It's like developer stuff like Homebrew version or like MySQL 5.8 now has a vulnerability. I'm like, can't manage it through Kanji really. So
Yeah, for sure. Yeah, we think that's a really interesting space to be. Cool. Back here?
So Kanji's agent is just tailing the ESF log?
Yeah.
Is that how that works?
Yeah, we're looking for specific events, and we're looking for different patterns of behavior there that correlate with malware and with pups, yeah.
So if I was to start using Kanji EDR and there were infections on the device that happened ages ago in the logs,
Yeah.
maybe they rotated out to EDR file.
Yeah, we do, just like most products, right, when the device is first enrolled, right, we do a full system scan and look at everything to see if there's any threats present on the system. But, so that's good, right? But I think the real challenge is keeping up with new threats, right? And looking at new files. And so ESF gives us a way to do that in near real time with a really low performance impact or a real low resource impact on the system.
Okay, so there is a signature-based scan happening and
Yep.
the log tail.
Yep.
So if the Kanji agent was crashed and the device gets infected, that's still going to be found on it.
Yep. Yeah, and there's some things like a lot of the definitions are local, right? But there are some things where the definitions are being updated online. And so like another example would be the agent loses connectivity. It's gone offline, it's somewhere in a Faraday cage, right? There may be certain threats we don't know about until the agent reconnects. Yeah. But then we would find him on the next run just to close the loop there. Yeah. Cool. All right. Well, I think time is up. So thank you so much for coming. It's really great to see you. Enjoy the rest of the show and good luck.